Hello everybody, it's Nathan from Arcadius Ops, and today we're going to do some construction details on the Raspberry Pi drone, which is the PyHawk from Dojo for drones. I'm using the handheld camera at the moment because I'm going to be showing you some details of the drone, but the drone is from the drone kit, and today I'm going to do the first 12 items on the construction video that you get with the PyHawk. Right. There's 29 construction steps, and what I've done here is do those first 12. Now, the first 12 are the backbones of the construction. They involve a little bit of soldering. So there's the soldering. So as you can see, the soldering is there. Right. It's not really difficult. Alright, not really difficult to solder. Get your soldering temperature right, which for my lead-free is about 230 degrees C. So the soldering is pretty simple. There were no issues with the wires or anything. It's good quality wires. This is 12, is it 12? 16 SWG. The anti-vibration, you can see there, the anti-vibration. Alright. That was a bit tricky to put the blue rubber dampers in there. A little bit tricky. They do say this on the video. The Raspberry Pi that comes with the kit, we had a 2 gig RAM memory. It's a Raspberry Pi 4, and the 3D printed chassis that you get with it, that was good quality, but a little bit more about that later. And the PyHawk that comes with it is the standard PyHawk. You got version 2.4.8, and the chassis that goes on there, the mounting thing, does have a little slot for the Pi camera. You can see the Pi camera set up there. A little bit about the arms and the 3D printed. Now, what we did is all of these casting lines, all right, we scraped off a lot of the screw that came after casting. So you can see the little one there. Haven't quite finished that one. To reduce the weight a bit. I know it's not going to be a significant weight saving, but at Arcadius Ops, there are a few engineers who are also motorcycle racers, so they're a little bit obsessed by weight reduction. The same for the 3D printed chassis. Fixing plate down to the drone itself. This is the plate that the Raspberry Pi goes on, and this one here is the PyHawk mounting plate. We also got rid of all the 3D printing hairs, and we scraped off some of the start and stop points of the 3D printer. So we don't know how much weight we saved, but we have saved some. Obviously this is an aircraft, so weight saving is very, very important. It's going to be interesting to see what the flying weight of this aircraft is. We haven't calculated the maximum takeoff weight yet, but that's going to be an experiment we're going to do a little bit later. We've got our battery ready to go on, and the next thing we need to do now is step 13 to step 29, which is basically setup and configuring the ground control unit and figuring out what you need to do to program the Pi and the PyHawk to do autonomous missions. So that's all about it now. So the next videos will be fixing the GPS, fixing the voltage control. So the electronic speed controllers, which are there, they are not voltage controllers. They only control what the motors get. All right, whether they spin clockwise or anti-clockwise, or whether they will increase speed, or whether they reduce speed, because obviously lift is proportional to the square root of the speed of your leading edges on your propellers. The lift equation obviously is lift is CL plus half rho squared V squared S. So the V is the velocity of your leading edges, and that's perhaps the greatest thing that we can control on any aircraft. Okay, so that's all from me. All right, and I'll see you in the next video, which is step 29 up to step 29. Okay, bye.